Okay, this is the last lesson in this chapter, triangles and coordinate proof. We won't be covering everything that's in this chapter, just what I feel is necessary for us to be successful for the next level of math that we're going to take. So we've got the content standards listed and our mathematical practices. Previously, we've used coordinate geometry to prove triangle congruence. And now we're going to position and label triangles for use in coordinate proofs. And we're going to write some coordinate proofs. Our new vocab, only one word, coordinate proof. So we're going to talk about positioning and labeling a triangle. Now, as with global positioning systems, knowing the coordinates of a figure in a coordinate plane allows you to explore its properties and draw conclusions about it. Coordinate proofs use figures in the coordinate plane and algebra to prove geometric concepts. The first step in a coordinate proof is placing the figure on the coordinate plane. So looking at this example, we're going to use the origin and the axes to position the figure. That way we have some square ground rules where we're going to go. And it's easier to see if we use the origin and we place the base of the triangle along the x-axis, and we're going to place the triangle also in the first quadrant. We're working with all positive numbers that way. So since z is on the x-axis, we know that the y-coordinate is 0. The x-coordinate is d because the base is d units long, and that's what we're told, d units long on the coordinate plane. Now, since triangle XYZ is a right triangle, the x-coordinate of y is 0. So we cannot determine the y-coordinate, so call it b. So the 0, or the x is 0 and the y is b. So now let's check your progress. Which picture on the following slide would be the best way to position and label equilateral triangle ABC with side BC, W units long on the coordinate plane? You might take a note of what's here, pause it for a moment before you go on to the next figure. All right, so which one of these drawings best fits the description that you previously had? Very good. D. We've got a key concept. There are 4 steps for placing triangles on a coordinate plane. You might take a note of that. Keep it in your notes. It'll be handy when you're doing the assignment later on. First, we're going to use the origin as the vertex or the center of the triangle. We're going to place at least one side of the triangle on an axis. We're going to keep the triangle within the first quadrant if possible. And we're going to use coordinates that make computations as simple as possible. Yeah, the KISS principle, right? We're going to keep it simple. Now we're going to identify missing coordinates. Name the missing coordinates of isosceles right triangle QRS. So let's look at this for a moment. Where do you think Q would be? If R is C1, how would we label S? Well, since Q is on the origin, we know it's 0, 0. The x-coordinate of S is the same as the x-coordinate of R, so we know that's going to be C. The y-coordinate for S is the distance from R to S. So since QRS is an isosceles right triangle, we know that QR is congruent to SR. The distance from QR is C units, as you see here. So the distance from R to S must be the same. So the coordinates of S are C, C. So time to check your progress. Name the missing coordinates of isosceles right triangle ABC. So for A, we got 0D, and for C was 0, 0. Of course, we could rule out D right away. We knew that the C was at origin, right? So we were only looking at these. Very good. All right, now they're asking us to write a coordinate proof. I'm going to go ahead and show you some of this, but we're not going to delve deeply into writing a coordinate proof. Take a moment just to look at the first step, and if you want to, you can go ahead and stop the video at this point, because what you really need to know we've already covered, but for those of you that want to go a little bit further, I'm going to give you that opportunity to see an extra example beside what is in your book. We've got to prove that YW is perpendicular to XZ. And time for you to check your progress. You might want to draw this picture before you go on. And the answer is the product of their slopes is -1. Okay, very good.